Hello and welcome to 10B. This is our section talking about seashores in terms of being either erosional, which means that it's geologically in reference and basically it's actually controlled by geology, or it's a depositional coastline, which is actually controlled by the ocean and depositing material on it. So I would like you to draw both of these. For the erosional coastline, make sure that you actually make sure it's flat and it's got this cliff up here. This is where the ocean used to be, and the cliff here where the ocean is now, as well as wave cut terrace and sea stacks and tumbalos, which are tumbalos are actually a part of a rock section that's left, and then the ocean as it comes around and bends around this and deposits sand, and so this is the sand. And then this one is flat as a pancake. It's got submerged maybe river valleys for lagoons. It's got bay mouth bars, depositional type things, barrier islands, spits if it doesn't go across. But the big thing is that it's water moving into the area in depositional environments. Okay, what kind of seashore is this? Is this controlled by geology, or is it controlled by the ocean? And it actually looks like we've got rocks in all of them. We have a headland and a bay. We have sea caves. We have actually arches, forming arches. We have cliffs. This is definitely an erosional type ocean. And here are depositional examples. This is Cape Cod. Boston's like up here somewhere, but this is actually a big sand area that's stuck in. This is some barrier island. I don't think it's OBX. I think this is down in Texas, maybe Galveston area. Tumbalo again with sand being deposited back below. And this is a picture down in Florida with a flat beach that's actually being nutriated. We're actually bringing in sand to replace sand that's been washed away. This happened, I think this was at Christmas break this past year, down in southern Florida, Atlantic Ocean side. Erosional type shores. I'd like you to draw this, and again we're actually starting with a crack, and then the crack grows and becomes larger into a sea cave, and then becomes larger into an arch, and then the arch breaks and we actually get sea stacks and eroded sea stacks, and eventually it's gone. So headlands erode, sea arches form, sea stacks form, wave cut cliffs. It's going to give a flat area, so if this actually does continue to uprise, we'll actually get wave cut cliffs. We do get sea caves. It is a tectonically active area, so it's more devised by geology than it is by oceans. An example is the Pacific coast. There are a couple of things down here that I'd like to show you. This is an erosional path. This almost looks like it's maybe the cliffs of Dover. And what I'm going to do is I'm just going to push play a little bit. You can see as the cracks, natural cracks inside the rock enlarge, we can start getting sea caves, and then we can get arches, and then eventually the arch breaks and we get a sea stack, and then the sea stack will eventually erode away and we lose it. And then if we go to, let's actually do this one. This is Old Hairy Stack. Which one of these things do you think looks like a stack? Let's move that there. Which one do you think shows the chalk bedding plains? In other words, flat bedding plains, which I'll show you. I think it's that one. Which is the headland? Only one that's left. Wave cut platform. Probably like that area right there. Cave forming. That's probably this one. Site of collapsed arch. And arch forming. And this one's a little weird, whether it's this one right here or this one right here, but I think it's this one. And then we can actually check these, and it looks like we did well done. And then if we go back into this one, there's this one down here also. Shockwaves, these are not going to work in Apple. And remember we talked about the round circle, the net motion of water molecules, and the gross motion is to start back where we left, and that works as long as we don't get the breakers. So they get elongated, they stand up, and I think you can maybe see they stand up, they get closer together, and eventually they break. But what I wanted to show you was this one. Okay, so waves come in, they get bent around this area, and they'll start eroding this area, and they'll deposit because the waves are actually bending out. So the energy decreases here, it's focused at this area, and it deposits the sand on these bays. Okay, so here are the cliffs of Dover, and there are the bedding plains, and there's a sea cave forming, and there's an arch, and there's a sea stack, and that's a wave cut platform, and we're going to get another wave cut platform as we erode these things away. So we have the place where the ocean used to be. These are actually sedimentary limestone areas, and each one of these things is a very large amount of time. Remember, they get older as they go down, but eventually if they get up, normally we get deposition below the ocean surface, and then we get erosion above. So as it actually gets pushed up above sea level, it starts eroding away, and you can see it actually is eroding in these areas. Here's another one. This is the Pacific coast. This one was probably over in Europe. This is the Pacific coast of the United States. Beautiful arch, sea cave, sea stack, old sea stacks, which are going to give you the new wave cut platform, which you can see up here as well. You can see lots of headlands and stacks and maybe caves all along this coastline. Depositional type shores, these are going to be sediment where this is when sediment gets redistributed by ocean processes. It's kind of important to understand the facies. Facies are actually plots of land that are actually controlled by depositional environments. We normally get sand really close to the beach, and as the material goes out, it gets smaller and smaller. We get sediment, shale facies out here where we actually get clays falling down, and then eventually we get the limestone where we get the biological life, or we get precipitation of calcareous sediments to give limestone facies. So deep calm ocean, we get limestone. Deep sediment filled, we get shale, and then sand near the beaches, we get the sandstones. Typical, this is in tectonically passive areas. So we don't have tectonics. This is like the east coast of the United States. And this is the Grand Canyon. And if you take a look, we actually have limestone. That limestone was way down deep in the ocean when it formed, but now it's 2 miles above. We have more limestone there. We've got a Kokona, that's not how you pronounce it, Kokino sandstone. That was located right around here when it formed. There's a shale, which was located out there. Another sandstone. So as we actually see sandstone, we can see that the water gets lower. In other words, there's an uprising. And as we get limestone, we got a subsidence of land where we get the limestone putting on top. So you can see this. And here's a larger version. This is a shale. It was located right there. Looks like more shale. There got limestone, so it got deeper, so the water got deeper. Another limestone, then it got shallow again to put the sandstone on top of it, and actually it worked this way. So this is all this is Precambrian rock. There's the Cambrian area, Mississippian, which is in the Paleozoic, and then we actually start the Mesozoic here, but the Mesozoic on, which is the rest of the Mesozoic and the Cenozoic, that material has been eroded away. So if there was something in the rock record to give us a key, it's gone. But if you take a look at it, we have Precambrian rock, we have got crystalline metamorphic rock, really, really old rock sitting on top of it. We've got metamorphosed limestone and shales, and sitting up above it are all sedimentary rock. We've got a sandstone, so the ocean level was there. We have a shale, it got deeper. We have a limestone, it got even deeper, and then more limestone, it stayed deep. And then it actually got another canyon formation. It looks like it's the shale in a limestone, so it looks like it got a little shallower, and then it got deeper again. And then we have another shale. And then we move up to, this is probably a sand, actually these are probably all sandstones. So it actually got shallow again, another sandstone, another shale, got deeper, another sandstone, it got shallower, another limestone, it got much deeper, and we can actually tell ocean level based on this type of rock that's there. Here's a picture of the Grand Canyon, and this is the Coquina Sandstone. Really wide area on both sides, but above it are shales and limestone, so the water just level changed. And then the rock that's up here is the very last part of the Mesozoic. So the Mesozoic, the rest of the Mesozoic rock and the Cenozoic rock, that's all been eroded away, carried away by the Colorado River out to the Pacific Ocean. And I actually don't know if this is a west view or an east view. This is a path that you can walk down. You can see somebody standing right here. The person that's taking the picture, I did not take this picture, although I've been on this path. The person here is actually on the cutbacks. They're up a little higher. They'll be down here if they're going down, or they're climbing back up. I don't know which way it is. Really be nice if there was an escalator. But these things, the paths actually try to take areas that are relatively flat. So, you do a lot of this motion going down. So it's only about a mile high, but you can do 8 or 9 miles of paths going down. And here's one section sitting. It's probably sitting on this level right there. So it does take a while to go down, but as you go down, you get the riparian type attitude. So you get lots of water and you get green plants, which you don't really get anyplace else in this picture. Depositional features. We have spits that stick out around bays. Tumbalos, which we have here, sand deposition behind sea stacks or some sort of a more permanent area. Bay barrier, which we actually close off a bay, and then barrier island, where we actually have protective sand bar above sea level, and a lagoon that's behind it. Barrier islands, normally we have an ocean beach. We have a dune made out of sand. Behind the dune, we have the barrier flat, which is a flat area. Usually it holds water pretty well. Saline water, so these have to be salt. Basically plants that can do with high amounts of salt. We have a high marsh and a low marsh, and then we get down to the lagoon. And as the water level rises, these barrier islands are actually pushed toward the land. So here's the ocean. So as the ocean level goes up, it'll actually push the ocean beach back. It'll wear away the dune. It'll push the sand back, covering up the barrier flat. It'll push the barrier flat over where the high marsh, and the high marsh where the low marsh, and the low marsh where part of this lagoon is, and it will keep moving in this area. So you can see this peat bed actually formed by lots of organic matter there. It can actually be placed all the way out to the ocean and give rise to a darker beach area if the peat actually is that close. But you can see that the peat gets covered by the sand if we get a rising sea level. It goes the other direction if we don't. Deltas, this is where we actually get river type material called fluvian material, actually carried by the river and actually deposited as the river spreads out and loses its energy. River deposits sediment near the coast. Big rivers, much more sediment than smaller rivers. If you've ever seen the Occoquan would have a delta, except that it empties into the Potomac River. But if you've ever seen the Occoquan after a rainstorm, it's carrying a lot of sediment. If there's more fluvial, which means ocean influence, then we actually do not get this kind. This kind actually looks like it's developed by the ocean. We get what's called the birdfoot delta. And if we get more ocean influence than river fluvial, then we actually get this arc-shaped, arcuate type delta. And this is the Mediterranean Sea. This is the Nile River, one of the only rivers that flows south to north, which is kind of cool. But this is all material that the Nile River picked up, and as it spreads out, it deposits that material. Really good for farming. Now we have a dam located up there now that actually stops the river from flowing, which is making this area less fertile. So we now have to use more fertilizers. There's the Suez Canal, which was actually made to drain parts of this area, and also have places where we can bring ships in and eventually get to the Nile River, where it's deep enough to actually go farther into the continent of Africa. Here are Bird's Foot, where we actually have sediment, and the sediment comes down faster than the ocean can actually wear it away. This is called a Bird's Foot delta. Not really quite a bird's foot, but you can see why maybe it's called there. There's New Orleans actually sitting on top of the Mississippi River Delta, far away from the continent itself, like 20 miles out. So you can actually see that the level of New Orleans is not very high. In fact, most of it is located at or below sea level. So they have levees and they've got pumps, and this is the big lake that's just north of New Orleans that caused a lot of problem for the lower income areas of North New Orleans when Katrina came through, because it brought up a storm surge which raised the level of all this ocean, which covered most of this area, including New Orleans, and even flooded part of Baton Rouge farther up. But that's the Mississippi River, and you can see it actually is broken up into parts. This is the part of the delta that's probably way over here, and you can see it's still trying to make a bird's foot delta. And what that basically means is as the water comes in, it deposits sediment and it can't go this way anymore, so it breaks over here, and then it can't go over here anymore, so it breaks over here, and then the next flood may actually break through that barrier, and eventually it just starts putting more and more sediment, and the North American continent is washing down the Mississippi River, and it's filling up the Gulf of Mexico. And this is what we think actually happened. This is part of the Mississippi Delta that happened 46,000 years before present. And then you can see the pink area came through, and then the green area came through, and then I don't know what area that one is, that one right there, and then this one came down, and you can sort of see it that the last one is actually this one right here, and you can see because it's on top of this one, which is underneath this one, and it's on top of this one and this one and that one. So this is the most recent, 550 years before present, and New Orleans is sitting right there on top of this last depositional area. This is wetland area that's actually being flooded, taken away, because wetlands don't want to be all salt, which is the purple area. They want to be this kind of blue area, and you can see that it's going through. So New Orleans, which is located about right there, would have been in a much better state back in 1839, maybe when it formed, and eventually it's getting closer and closer to wet areas because the delta is both sinking and sea level is rising. Bad for anybody sitting on top of relatively low topography. Shepherd classification, last thing we're going to talk about, we have what are called primary coasts. Primary coasts are the first ones that are there. They're usually geologically youthful, so they're actually where water's coming down through the rivers and wearing away the land. The ocean's coming in and wearing away the land. Controlled by non-marine processes, so basically it's controlled by geology, and examples are drowned river valleys, like the Chesapeake Bay, volcanic coasts like the west coast of the United States, and coasts that have recent tectonic movements are the basic idea for that. Then we also have what are called secondary coasts. Secondary coasts are geologically mature. It's not controlled by geology usually. It's now controlled by marine processes. These are mangrove plants sitting on top of marsh areas, and what happens is the roots come down and they stop the sediment, and it actually starts making land there. So it's actually controlled by marine processes. It is tectonically passive. Examples of this would be straightened coasts, and if you take a look at the west coast of the United States and the east coast of the United States, the east coast is much straighter. Coral reefs, marsh grasses, and then we also have what are called emergent coastlines. This is where we actually get land lifting up out of the ocean, and we get sea level to make cuts, and then wave platforms, and you can see wave platforms up here. You can see newer ones being formed down there, and sea stacks, and probably arches, and sea caves, and all that stuff. So this is the erosional type coastline too, but we call it emergent coast because they're coming out. There's a picture I'd like you to draw these. And then we have submergent coastlines where we actually get the land probably falling down, and then we get the continental shelf wide, and then we get a slope way out there, and what basically happens is the land is moving and we get this land, the sand stone type material forming right there, and then we get more coast going on top of it. So this is where we can actually get the sandstone, which is located right there, and then we can get it to move down as the ocean recedes, and then the elevated sea level, which we're getting now, which is the submergent coastline, where we actually start getting shales on top of the sandstone, and we get limestones on top of the shales. And this is a really good example of this type coastline. That's what we see on the east coast of the United States. Subsidence or sea level rises, once land or shallower, now underwater and deeper. Drowned beach deposits, drowned river and glacier valleys, and submergent dunes, where we actually find the dunes underneath the water now. Tectonically and isostatic changes. Isostatic we talked about back with plate tectonics, tectonic uplift and subsidence. Large scale, major parts of the continents have had water on top of them at some point, salt water on top of them, and they've risen up. Smaller scale, depositional, local deformation caused by convergent type plate boundaries. Isostatic adjustments, where we have sediments or ice sitting on top of the land where the stuff actually sinks down because of the extra weight. Then we have regional and local effects where, again, where we have the beaches close to it, or we may have a volcano throwing material on top with sinking. We may have ice melting in some areas where actually the land is now rising. These are what are called isostatic adjustments. They adjust up and down based on the addition of mass or the removal of mass. Global warming, regardless of cause, is going to cause this. So if man is causing it, if space is causing it, if Earth is causing it, it doesn't matter what's causing it, it's going to cause lots of tectonic and isostatic changes. Melting of ice, north and south poles, pushing up of continents because of the offload of the masses, and they will all affect sea level. So all these uplift, subsidence, isostatic adjustment either way, and global warming are all going to affect the sea level. Eustatic changes in sea level. If you take a look at this, this is sea level drop below present millimeters. So you can see glacier maximum, sea level went down. And this is thousands of years before present. Actually right here, we had glaciation and the land actually went down. And then as the ice melted, the land goes back up, and you can see it goes up, and this is in meters. So 120 meters times 3.3, 60, that's almost 400 feet of pushing down and now coming back up. So this is global. Changes in spreading rates of ocean floor, changes in ice volumes, changes in ocean temperature. Ice volumes will again push down sea level, okay, covering it with water, which will eventually freeze to make the ice sheets. Changes in temperature, as you raise the ocean temperature, it will rise and get deeper. Global warming, probably global climate change is better because some areas do get colder. Sea level rises because the temperature of the planet is warming, and the sea is, regardless of whether the ice is melting and going into the ocean, sea level rises because the ocean actually expands. And ice melting is going to fill up the ocean. Ocean warming going to make the ocean go much bigger. And that is the end of this section. So thank you for 10B. Bye.